2023, there was a 400% increase in cyber attacks on IoT and network devices in the industry. So that's led to some serious regulation and standards that are coming into play today for cybersecurity of products with digital elements. And in way of protecting those, firmware security has become paramount, the greatest level of firmware security being platform root of trust. So, able to accomplish that, we have a hardware root of trust device, and the latest of those is the Lattice MachXO5D FPGA controller, providing hardware root of trust with the AMI Tektagon platform root of trust firmware. Together, they will provide support for Intel PFR 4.0, I3C support. They will do host CPU attestation, and they will have post-quantum cryptography. In terms of supporting post-quantum cryptography, we will support the CNSA 2.0 standard of crystals, dilithium crystals, Kyber algorithms, and together those will prevent against any sort of compromise of any keys using a quantum computer. So in this example, we will do T-1 validation of both BIOS and BMC firmware using the MachXO5D hardware root of trust FPGA and the AMI Tektagon platform root of trust firmware.
What we are going to see right now is the Tektagon PROT solution running on the Lincoln City platform with Lattice MachXO5D PROT SoC. We can see that the recovery region has verification has started for the BMC here. It is currently validating the recovery manifest on the region information specified in the manifest. Once it is validated, it is going to start the active BMC region verification. Now the recovery region has been successfully validated and it is starting to verify the active region. All the region information is specified to the Tektagon firmware using the manifest. The manifest has information about the region start address, the size, the hash details, the digest details of that region, and it is going to calculate the hash based on either ECDSA or PQC and validate the region. Once a region has been, BMC region has been successfully validated, it is going to proceed to the PCH validation or the BIOS recovery region validation. The same process is repeated here, but this time for the BIOS. Once the region is validated, it is going to perform the active region validation for the BIOS. Currently, it is we are looking into the region start address and the region size and validating them. And once this region has been successfully validated, it is going to proceed to SPI filtering, enabling SPI filtering. As you can see here, the SPI filtering regions have been enabled. These help Tektagon protect the SPI from unauthorized write access. So thus it is going to make sure that during runtime the BIOS or the BMC SPI are not tampered with. And once this operation has been completed, it is going to release the BIOS and the BMC to boot.